What we have expressed here is the relationship of free energy, non-standard state, to free energy standard state plus RT ln Q. And we'd like to express this under two sets of conditions and see how these relationships then correspond to one another. So if we just go ahead and look at this here, we have delta G non-standard state free energy, in which reactants and products could be at any concentrations. And this would be the standard state free energy, in which if the reactants, all the reactants and products, if they're gaseous, they have to be at 1 atmosphere under a defined temperature, pure at 1 atmosphere under a defined temperature. If they're aqueous, they have to be at 1 molar under 1 atmosphere at a defined temperature. And its solids and liquids do not appear in the expression, but they would be pure under 1 atmosphere. That would be the standard state. There is only one unique value to the standard state free energy. Delta G is if any of those reactants and products are under non-standard state conditions. And then we have R, which is our R constant, T is temperature, and ln Q. And just to remind ourselves here, if we're looking at it, R is our R constant at 8.3, our thermodynamic R constant, 8.314 joules per mole Kelvin. And then the temperature would have to be in Kelvin to match units with the R constant. And Q is our reaction quotient. And that would be the law of mass action in which the reactants or products are under any concentration values. So we will go ahead and take this expression and express it under two sets of conditions and see how the relationships relate to one another. So let's go ahead and identify this. We're going to write down delta G equals delta G0 plus RT ln Q. And at standard state, what occurs in this expression at standard state? At standard state, we know that the reaction quotient equals a value of 1. Because that's the definition, be it gases or aqueous, all the values are at 1 atmosphere or molar. When Q equals 1, the natural log value of 1 equals 0. And so under standard state conditions, the natural log of Q is 0, and therefore our relationship is delta G, the free energy, equals the standard state free energy. And that's that relationship, so it's self-consistent with at standard state. What is the free energy for the process, for the reaction? It equals the standard state value at standard state conditions. The next condition we'd like to see what occurs here is when we are at chemical equilibrium. So let's start off here. Once again, we have delta G equals delta G0 plus RT ln Q. And we're going to see how this expression relates to the terms to one another when we are at chemical equilibrium. Okay, so when we're at chemical equilibrium, delta G, the free energy, equals 0. We are at chemical equilibrium. So the delta G equals 0. The reaction quotient equals the equilibrium constant. And therefore, under these conditions, we come along here and say, okay, this is 0. This Q equals the equilibrium constant. So we're going to have 0 equals delta G0 plus, now we're at equilibrium, RT ln KEQ. And then the expression here is, this actually provides us the expression, the relationship between standard state free energy and the equilibrium constant, which is delta G naught equals RT ln KEQ. And one can calculate the free energy from the equilibrium constant and vice versa. That's the overall free energy term under two sets of conditions at standard state and now at chemical equilibrium.